Recordings rolling for February, October 15. You guys turn in your Chapter 7 homework. Off camera, I recap for you guys this TED Talk by Patricia Burchett. So I do encourage you guys to go watch that in case I don't have time to share that in class. And you guys remember also, skip down this last one, that your Open Notes take-home quiz is due Monday. Some of you guys have turned that in already. But the main focus today is going to be this turntable lab. Okay. So do you guys see, clip to the front of your desk, a page that looks like this? Have this? Okay, so we're going to have you guys figure out the coefficient of friction between two surfaces by spinning a turntable. Okay, so here's the mechanics of this thing. I've got this turntable down here. I can throw different objects on it. I've got little stuff around here. We've got a coin, a binder clip, a pick. There's a bunch of little knickknacks back there too, like this. To show you. So just one at a time though. Let's say pick the binder clip. What's the coefficient of friction between, say, this binder clip material and this wood surface? Okay. Well, do you think you could determine it by spinning this? And then if you spin this fast enough, this thing will eventually fly off the edge, but because of inertia. Okay. Where would it break the friction? Well, that depends what the coefficient of friction is. And actually, just that motion right there, you could go back and watch the video evidence and actually calculate what the coefficient of friction is. So take you guys through this process. Okay, so you have some object here on the surface, you're spinning it, has some omega value, like radians per second spinning. Okay. So this is actually a classic lab that AP might have you do a write-up for an FRQ. It totally could be. Actually, I think it is one of them. I'm going to have you guys skip the write-up today, just do the table because, well, lots of reasons, but we'll just do it that way. And so under trial number, instead of a number, write the object that you're doing. So pick at least 3 objects. So maybe you could do like if you have a coin or you see one back there, maybe you see like an old Lego piece. Maybe you see like a binder clip. Maybe there's a guitar pick back there. Maybe there's some Play-Doh lit tape dispenser. Okay. So if you do at least 3, I think you should have plenty of time to do that today. And yeah, just do 3 and then it'll be done for this lab. Okay. All right, so you guys know gravity field is 980 centimeters per second squared. Have you guys measuring centimeters today? Then begin this law work out. Right? So measure this radial distance from the center in terms of centimeters. So how far is your object from the center? Right? In terms of number of centimeters. So this would be, if the center's right here, this looks like about 10 centimeters right here. Right? So it'll probably be pretty close to that for your radial size. Then the process is, we'll speed this up spinning until the thing slides off. And at that moment, you have to figure out what the angular velocity is, omega. How do you do that? Well, that's how far it turns per how much time. So treat how far it turns as 1 revolution and time. What is the time for 1 revolution? Now, in terms of radians, you guys know that's 2 pi radians, right? Okay. So if it takes however much time, take a few times, take an average, that makes sense, right? It might be like a fraction of a second. Okay. And then if you divide 2 pi radians, which is 1 revolution, by the average number of seconds, wouldn't that give you radians per second, right? That's what that would be, right? And then finally, coefficient of friction. All you have to do is plug into this expression right here. Right? Now, since you guys are AP, I've really told you too much stuff, but I mean, we got a short Friday, all whatnot. Right? This whole derivation above this very last column, that's what Lisa's column tells you coefficient of friction based on all these other variables. Right? I'll take you guys through it really fast, but ideally, this is something that you're supposed to come up with from scratch by yourself. Right? That's sort of the AP expectation. So I'm helping you guys out, probably way too much, but that's okay. So this thing spinning. The friction force is acting as a centripetal force. You guys know friction force is coefficient of friction times normal force. And centripetal force, well, here's one of your foremost, right? One of your expressions, m omega squared r. Right? Then normal force is mg, so you sub that. Right? It's still equal to that expression. The mass of the object cancels. That's why I never had you guys measure the mass, although that would be a good step, but it cancels. Right? And then finally divide the g over, and that's how you get this expression right here. Right? You guys see that? Follow that? Right? Now, again, that's something that you should be able to do on your own from scratch. So be able to have that skill. That's how it works out. Right? But then once you got these other columns, just plug in there and get the coefficient of friction. It should be in the ballpark of, I don't know, maybe 0.2, 0.3, 0.4, somewhere in there. Like if you get coefficient of friction is like 0.27, then great, that definitely looks reasonable. Okay. right, any questions about this? All right, so you guys got the rest of the class. To do this, just do at least 3 rows and you are gold for the week.